Hi everyone, this is the first video for section 9.1 on rational numbers. So rational numbers, we've talked about them before. Back in chapter 2, when we first started talking about sets, we talked about sets of numbers. And if you've noticed, so far in this course, we've essentially just been talking about those different sets of numbers. So we've already talked about the natural numbers, the whole numbers, and the integers. And we've also talked about fractions. So we can think of the rational numbers as merging fractions and integers. And so because of that, I don't know if you've also noticed that it seems like these videos are getting shorter and shorter. And it's because all of this is building on each other. Because we've talked in chapter 8, we talked less about additions, subtraction, multiplication, and division of integers because it was really similar to everything we knew about whole numbers. We just added in some signs and we just really had to see how those signs change things. And so the same thing's going to be true here in chapter 9. We've already talked about integers and we've already talked about fractions. So when we think about the rational numbers, they'll have a lot of the same properties as the fractions and the integers. So it's really a review of the old concepts, just kind of combining them in different ways. So I know we're all glad this is the last chapter of the whole year, and it's going to be one of the shortest. So that's great. So remember from what we talked about in chapter 2, that a rational number is just a number whose value can be expressed as a quotient or ratio. Remember, we talked about that in chapter 6, of two integers a and b, written a over b. And so the rational numbers can be represented by the set q. So we can also write q like this. If you're writing it down, you just write the circle and then a line there, and then you finish up your q. So this is represented by the set q. So it is just, oops, these z's should be that, let me see if I can, these z's should be the Blackboard bold one. Oh, that is too small. So these z's should be the Blackboard bold ones, so these integers. Okay, here we go. So a fraction is just one integer, a rational number is just a fraction where both of the numbers on top and bottom are integers, and you just can't divide by 0, right? We've not been able to divide by 0 this whole time. So a rational number is just the subset of fractions. Remember, we talked about subsets. So it's the subset of fractions that only has fractions that have integers on top and bottom as numerators and denominators, right? So one thing to note is that q is a subset of the fractions, right? Because every rational number is just a fraction with only integers. So every rational number is a fraction, but every fraction is not a rational number. And we'll talk about that in a minute. So also, if you're already confused and you don't remember what a subset is, go back to the material in chapter 2. We're about to talk a lot more about the sets of numbers and subsets and things of that nature. So make sure you know what I'm talking about when I say subset. Okay, so we have an alternative definition that we can use to talk about rational numbers. So a rational number is a number whose decimal form either terminates or repeats. So remember that a fraction has a terminating decimal. If the denominator only has prime factorizations that have prime factors 2 and 5, right? And that's because we can always change that denominator by multiplying by powers of 2 or 5 to have a denominator that's a power of 10. And other decimals repeat. Remember that whenever we can identify a repeating decimal, if whenever we divide that fraction, we do that implied division. Whenever we divide it, we end up with a quotient that was the same thing that we started to divide by. So a rational number is always going to be a number whose decimal terminates or repeats. So everything that we typically work with is of this form. However, there is a subtle difference between a fraction and a rational number, right? We said the rational numbers are subsets of fractions, right? Every rational number is a fraction, but not vice versa. So we can list fractions that are not rational. So when we list fractions that are not rational, these are things like the square root of 2 over 3 and things like pi over 4 and things of this nature, right? Where one thing, either our numerator or our denominator, or potentially even both, are not rational. Or remember, rational is are not integers. So we can have a lot of fractions that aren't rational, and these are things that we deal with a lot. They come up a lot more often than you think. I know that it's likely that none of you have ever seen a calculus class, but things like square root of 2 over 3 and pi over 4 come up a lot in calculus and a lot in other courses. So we have all of these fractions that are not rational. It just means that something in the numerator or the denominator or both are not rational or not integers. So we also have rational numbers that don't look like fractions. So you remember, if we're saying that the rational numbers is a subset of the fractions, remember that means that every rational number is a fraction. And that's true. However, that should be fractions. However, it's often that we think about rational numbers and we don't think about them as looking like fractions, because we have rational numbers as -1, 0, 7, -16. We have all of these numbers that are rational. Remember, because any integer we can think of as a fraction by just putting it over 1. But oftentimes, when we think about these numbers, we don't think about them as having a numerator and denominator. We just think about the whole number part here. So oftentimes, when we think of these numbers, they don't look like fractions, but they are rational numbers, because we can think of them, any integer is a rational number when you think about it over 1. So that tells us that the integers, well, I'll write it here in blue. That tells us that we can think of the integers are a subset of the rationals. And this is because of this reason we just talked about above. All integers can be thought of as a fraction by putting it over 1. And because 1 is an integer and the number we started with was an integer, these are fractions of the form integer over integer. And then we can think of the things that we would normally think of, the fractions that we typically use. So things that are both fractions, well, we have rational numbers that look like fractions. And these rational numbers that look like fractions are just the fractions that we see every day, right? It's most of the things we dealt with in chapter 6. We have -1/2, 10/8, 7/12, things of that nature, right? The fractions that we typically deal with in operations, these are the fractions that are rational numbers. And that's just because we tend to not think about things as complicated as square root of 2 over 3, pi over 4, when we're doing elementary school math, right? Remember, this course is elementary analysis. The point of it is for people who want to go into education. So yeah, so these are the things that we typically look like, are fractions, are rational numbers that look like the fractions that we know and love. Okay, so one thing I want to note here while we're talking about how all of these things are written is that there's a lot of different ways to write how a negative rational number. So we could either have a negative sign here in the numerator, a negative sign here in the denominator, or out in front. All of these are correct, but the one that's used most often is when we have a negative out in front, this last form. So this one's just the most common. I don't know, it may not be the most common for you. You know how you write out these things. So this one is the one that's most common in general mathematics. And even if you notice in the textbook, even on the first page of this section in 329, they put the negative signs out in front of the fraction. You may not prefer that. You may write in a way in which it's easy to get your negative sign confused with your fraction bar, and you may not like this. So any of these are valid. They're all equivalent things. They're all equivalent things. And you can see this whenever you think about, we had this property back when we were in the multiplication chapter, that negative a times b was negative ab is a times negative b. Whoops. Right, we had this property in the last section on multiplication. And remember that we said all of the sign rules that we had for multiplication are also true for division. So this also tells us that negative a over b, if we just change everything instead of multiplication, if we just change it to division. So negative a over b is negative a over b is a over negative b. And this just comes from that property that we had. That all of these are equivalent because we had this property in multiplication. Okay, so we can write these in any way, and they're all equivalent. So this is just kind of a basic introduction to rational numbers. In the next video, we'll talk more about how the rational numbers fit into the scheme of numbers overall, and it'll make more sense whenever we talk about it, and then different properties that they have.